University. So today's presentation is on role of financial and economic means in accelerating renewable energy and uh, in the era of climate change. So this is a study that I and my colleagues we have done using Chinese data, and the paper has been published in Economic Analysis and Policy. So it's my pleasure to present it today. So we are familiar with the significant impact of climate change on our life and on our environment. So the climate change, that the main factor behind it is high level of emissions, has been a critical issue and had significant impact on quality of life, on social stability, and as highlighted by several studies by international organizations, government, and so on, the high level of energy consumption, especially fossil fuels, coals, oils, natural gas, is the main reason behind the high level of emissions, greenhouse gas emissions, and the climate change that it caused. So China is also among the largest carbon emitters due to the high economic growth and massive demand for energy. China had significant carbon emission. So when we are looking at the data, we see that from 1978 to 2020, Chinese energy consumption rose from 0.57 billion tons of standard coal equivalent to almost 5 billion TCE. That fossil fuels accounting for about 84% of this in 2020. Although Chinese government has set lots of plans and ambitious goals for reducing fossil fuel consumption and increasing the share of renewable energy in the energy mix, but it needs to be more. Therefore, in order to set the right policies, it is important to look at the factors that have impact on renewable energy growth. So when we are looking at the renewable energy goals in China, we see that China has a significant plan, and the aim is to achieve the carbon emission goal by 2030 and reaching the carbon neutrality by 2060. The guiding opinions on energy work in 2022 issued by the National Energy Administration in China, emphasizing the increasing the share of non-fossil fuel energy in the total energy consumption to about 17% and enhancing the contribution of photovoltaic and wind in the total energy consumption. However, what are the challenges in renewable energy development? So despite the ambitious targets, China faces significant challenges, including regional disparity in renewable energy development, the need for substantial investment, and technological innovation. So these are the three main challenges, because when we are looking at the renewable energy development, there are some provinces that had a significant growth. However, there are some other provinces that lagging behind. Investment in many sectors relying on government financing. However, private sector needs to be more active in this matter, and technological innovation, especially for those types of renewable energy that needs higher level of technology. For example, hydrogen or higher efficiency photovoltaic, higher efficiency wind turbines, and so on. So uh, these technologies needs more innovation, more technological innovation, and because of that, more research and development. Another thing is utilizing financial innovations. For example, fintech, with its innovative financial solution, presents a promising avenue to address the challenges by facilitating investment and enhancing the efficiency of renewable energy. So when we are looking at the renewable energy consumption of 30 provinces in 2020, when we looked at wind power, hydropower, and solar energy, we see different provinces. Sichuan province is, has the highest level, Yunnan, Hubei, and other provinces, and we see the share of different energy. So regarding the research questions, the questions that this research aimed to answer, there are 4 questions. Does fintech as a financial innovation lead to an increase in renewable energy growth? So this question examined whether fintech promote renewable energy growth in the context of digitalization. Secondly, does the effect of fintech on renewable energy growth vary depending on the level of REG? This question explores whether the impact of fintech on renewable energy growth differs across regions with varying level of REG. What is the role of digital economy? What is the role of digital economy in the nexus between fintech and renewable energy growth? So this question investigate whether the digital economy can assist fintech in achieving greater renewable energy growth. 4th question is, how does fintech affect REG? This question delves into the specific mechanism through which fintech influence renewable energy growth. And this study has 3 major contributions to the literature. So first of all, the study aims to be one of the first to examine the impact of fintech on renewable energy growth in China. This has reference value for the Chinese government and also for other countries that have a plan to increasing the share of renewable energy, as it will help them to formulate renewable energy growth strategies considering the integration of fintech and by providing empirical evidence. So the study enriches the research landscape on the intersection of financial, technology, and renewable energy. Secondly, the research investigates the impact of fintech on renewable energy growth at different levels of renewable energy growth across various provinces in China. Because as I have mentioned, Chinese provinces and different parts of China are in different level of development of renewable energy. So it is important to assess the heterogeneity. It is important to assess the impact of fintech on development of renewable energy, on growth of renewable energy in different provinces. Then, based on that, it is, insightful policies, practical policies will be extracted. Recognizing significant regional disparity, this study offers crucial insight for developing differentiated strategies tailored for provincial needs. Additionally, the study explored the synergistic effect of fintech and digital economy on accelerating renewable energy growth, employing a moderating effect model to highlight these interactions. The study delved into the transmission mechanism through which fintech influence renewable energy growth, providing a deeper understanding of this connection. These insights are vital for policymakers to design effective strategies that leverage fintech for sustainable energy development. The findings also serve as a valuable resource for future research by scholars and government, guiding policy formulation and academic inquiry into the role of fintech in promoting renewable energy growth. Studies on fintech. Before running our empirical work, we have done an extensive literature review. So, first of all, we looked at the studies on fintech and renewable energy. So, some scholars argue that the development of fintech can significantly influence renewable energy growth, such as Zhao et al., who found that fintech platforms such as crowdfunding and peer-to-peer lending reduce financial barriers and support renewable energy projects. Or my earlier study provide empirical evidence of fintech positive impact on renewable energy growth, highlighting the role of financial technology in sustainable energy initiative. This conclusion is supported by Ren et al., who emphasize the potential of blockchain technology to enhance transparency and security in transactions, making renewable energy investments more attractive. Also, there are several other studies that propose that fintech help improve the investment landscape for renewable energy, such as Zhao et al. Assert that fintech innovations like blockchain can streamline the investment process and increase investor confidence by providing transparency and reducing transaction costs. Or Esperon Rodriguez also support this viewpoint. Concluding that fintech solutions can effectively mobilize small investors and provide the necessary capital for renewable energy. So when we are talking about renewable energy growth, large-scale energy projects is important. For example, a few days ago, a huge project, a gigawatt solar project was launched in Xinjiang province of China. So these kinds of large-scale projects are very important for energy transition. But at the same time, especially for rural areas, it is important to develop smaller scale projects, such as solar rooftops and so on. So fintech has very important role for crowdfunding, for bringing a small amount of money, for running small scale projects or mid scale projects that should not be neglected. And it is important and it should be in the energy transition agenda. Or in another study, Khansari et al. 2014 or Ramaswamy et al. 2016 further reinforced these findings by demonstrating that fintech platforms can facilitate decentralized energy financing, enhancing the supervision and efficiency of renewable energy investment. So not only fintech has impact on easing the finance, but when we are looking at the digitalization as a whole, digitalization has an important role in enhancing the energy efficiency or in green technology innovation. such as Rehan and Nehdi, found that digital technologies improve energy management and operational efficiency. Or Smiley et al. Highlighted the role of Internet of Things and smart grids in optimizing energy usage and integrating renewable energy sources. This conclusion is supported by Lee et al., who emphasize the potential of big data analytics to enhance energy consumption patterns and efficiency. So this is important. Also, many other studies supported this idea. Dameri asserts that digital technologies can improve urban green total factor productivity by reducing CO2 emission and using more efficient energy. Or Liu and Peng support this idea. Liu and Peng support this viewpoint, concluding that digitalization shift the utilization of natural resources from a linear to a network structure, thereby saving resources and continuously improving efficiency. Khansari 2014 and Ramaswamy I also mentioned. So when we looked at the literature, we found that there are three gaps in the literature that I mentioned earlier, but here I depicted and it provided this picture which is more clear. First of all, there is a lack of consensus on fintech's impact on renewable energy growth. So studies show that while fintech is believed to enhance renewable energy growth, the nexus between fintech and renewable energy growth is rarely documented. Therefore, more empirical studies are needed to clarify fintech's impact on renewable energy growth across different contexts. Secondly, heterogeneity in digital economy effect. This is what I have mentioned, that the role of digital economy in the fintech renewable energy growth nexus is underexplored. Differences in digital infrastructure and regional development lead to varied impact. Some prefectures are in lower level of development. Some prefectures or some provinces are more developed. Therefore, because of different level of digital infrastructure, because of different level of financial inclusion, because of different level of economic development, the impact of fintech on renewable energy growth is vary. So it needs to be assessed empirically. Third, insufficient focus on transmission mechanism. Limited research on how fintech and digital economy influence renewable energy growth. Green technology innovation is a crucial component, and this study explores whether fintech impacts renewable energy growth through GTI, addressing the need for understanding these mechanisms. So in order to do this research, we have a panel data from 30 provinces in China. The panel is covering the data from 2006 until 2019. The dependent variable is renewable energy growth measured by installed capacity of renewable energy power for electricity generation. So it means installed capacity. And then the main independent variable is fintech adoption. So for fintech adoption, we look at the patents related to fintech based on AI. So the degree of fintech in the first year is measured by the number of AI patents related to fintech. And then for the subsequent years, we calculated the new patents and deducted the depreciation. So following Lin and Zhu and Ren et al. So the depreciation ratio is considered as 10% based on the literature. So we have also several control variables, including economic growth, gross regional product per capita, industrial structure transition, output value of the tertiary industry. We also have urban-rural population structure. Urban areas are more developed and have higher access to finance and higher level of digital infrastructure than rural areas. And also we have energy consumption. Next, based on the theoretical background and based on the explanation that I had, we have developed the econometric model to assess the nexus of fintech and renewable energy growth. We construct a research framework for the main factors affecting renewable energy growth. In addition to fintech, we consider the economic growth, industrial structure, urban-rural population structure, and energy consumption. So the detailed estimation model is as below, as I have mentioned, that reg is our important dependent variable, that it shows the development level of renewable energy in China. And also we have FT that gauge the level of financial technology, such as fintech. We have GDP, SER, URP, and EC, four control variables that I have explained them. So because unit of variables are different and they are not uniform, therefore assessing the relationship and magnitude of impact is different and it's difficult. Therefore, we use the variables in logarithmic format that reduce the possibility of heteroscedasticity problem in the data, but also effectively estimate the elastic relationship between the variables. So therefore, we have the bottom equation that shows the variables in logarithmic format, and here shows the definition, symbol of variables, and their descriptive statistics, and the source of data for each of them. So first of all, here we have our baseline regression. So using different methods such as OLS, fixed effect, random effect, FGLS, and instrumental variable generalized method of moment, IVGMM, we have got the results. So as it is clear in the last column on the right-hand side, and I made a red rectangle there, it's clear that the positive impact of fintech on renewable energy growth, with an increase in fintech by 1%, encouraging renewable energy growth to increase by 0.37%. When we are looking at our control variable, industrial structure transition, energy consumption, these are also positively impact renewable energy growth. While the urban-rural population structure negatively impact renewable energy growth. And also it is very clear. Model validation. So we use the instrumental variable generalized method of moment that is validated by a statistical test, KPLM statistic, and KP-Volt-F, that in both of them indicating that the results are robust and correct. So policy implication findings suggest fintech significantly promote renewable energy growth in China, highlighting the importance of supporting fintech development and addressing urban-rural population structure challenge to enhance renewable energy growth. So next we have done a robustness test. We have done a robustness test that in the robustness, we change the dependent variable and also control variables. Some of them, their definition changed, and the method of our estimation has been changed. Again, as it is clear here, we can see that the developing fintech is conducive to an increase in renewable energy generation capacity, and then result in the third column also basically consistent with our baseline regression. Therefore, in the next step, we are focusing on one point that I have mentioned earlier, which is the disparity, that I have mentioned, because companies are in the different level of, prefecture provinces are in the different level of development. Therefore, we need to assess the uh, different impacts of fintech on provinces with different level of development. To explore whether the impact of fintech on renewable energy growth is asymmetric, which means the marginal influence of fintech on renewable energy growth is different at different quantile of reg, we employ the panel quantile model to estimate the asymmetric nexus between fintech and reg. The panel quantile model is widely applied to detect the asymmetric effect in the literature concerning environmental and energy topic. The specific equation is as below. So here is result of our asymmetric analysis. The coefficient of fintech are all positive and significant in various quantiles, as it is clear here, which once again verify the positive fintech reg nexus in China. This also means that developing fintech is effective in increasing reg in all sample provinces, regardless of reg level. On the other hand, the marginal effect of fintech on reg changes as the level of reg changes. Specifically, at 25th quantile, the coefficient of fintech is 0.5049, while the figure decreased to 0.2884 at 19 quantile. This is to say, for provinces with a low level of reg, the role of financial technology in promoting the level of renewable energy is about twice that of provinces with high level of reg. So in another word, the provinces that have the low level of renewable energy growth, they have more rooms, more capacities to fill. And any effective technology, any effective policy that can bring investment into renewable energy projects can help to fill this gap. Yeah. Hence, the finding from the asymmetric analysis underlying that fintech is more effective and can play a more prominent and remarkable role in promoting REG in provinces with a comparatively low level of renewable energy. So this is what I have mentioned, and this is also an evidence for what I have provided. Next, we have done a moderating effect analysis. The development of fintech and digital economy complement each other. Yeah, because digital economy, one indicator of it is fintech development. Therefore, we intend to check whether digitalization can help fintech achieve better REG, renewable energy growth. To this end, we adopt the moderating effect as below. So where the LED denotes the level of digitalization in China, which can be represented as digital economy, we get the data from Wang et al. Variable. So empirical results for the moderating effect. So replacing fintech with DE shows that 1% increase in DE can trigger a 1.74% increase in renewable energy growth, highlighting that digital economy's significant role in enhancing renewable energy and facilitating the energy transition. When we add both fintech and DE, both exert a significant positive impact, as it is clear here. The interaction term between fintech and DE, which is here, fintech and DE, remains significantly positive, indicating that digitalization amplify fintech's contribution to REG and accelerate energy transition. Developing DE can enhance and boost fintech's effectiveness in achieving better REG. So this is also the moderating effect that I have mentioned. Although we find that positive fintech reg nexus exists, we don't know the mediating effect. We don't know how fintech affect reg. Therefore, to understand the mediating role, we use the mediating effect model to detect the role of green technology innovation. And we use GTI as a mediating variable. So moderating became through digital economy, mediating through GTI. So GTI, as I've mentioned, represents the level of innovation on green technology. And in this paper, we use the patents on renewable energy technology as a proxy for GTI. And the patent of renewable energy technology represents clean energy innovation. So based on the mediating variable and the above two estimation, the estimation from the equation, we first use GTI as a dependent variable and investigate the impact of fintech on GTI. Then we add the variables of fintech and GTI to the estimation specification at the same time to evaluate the direct impact of fintech and the mediating impact. So the first column of table 6, we know that the fintech has a positive impact on GTI, and a 1% increase in fintech lead to an increase of 0.18% increase in GTI. And then the column 2 shows that the both fintech and GTI effectively accelerate the process of REC. When fintech and GTI increase by 1%, the level of GTI can be enhanced by 0.27 and 0.53 representatively. Therefore, we can assert that GTI is the intermediary path in the fintech reg nexus or the mediator. So this is also important. GTI, when we have a higher level of GTI, renewable energy technology patents would be increased. Therefore, the development of fintech accelerate the development of this. GTI empowers fintech to improve the conservation rate of patent, adding commercial and application value to patents. The development of renewable energy patents, such as energy converter technology, solar PV module technology, distributed renewable energy grid, and renewable energy charging piles, has directly promoted the technological innovation of renewable energy and grid-connected power generation of renewable energy. So this figure is the conclusion, and this is what we have found out, that renewable energy is here fintech is here, mediating effect through renewable energy technology positively impact renewable energy and fintech digital economy. Moderating effect is through digital economy positively affecting. Therefore, the total impact is positive. So resulting from the baseline regression show that fintech positively influence reg, and a 1% increase in fintech is related to a 0.37% increase in reg. Hence, progress in fintech is crucial for accelerating the process of reg. The results of asymmetric analysis shows that fintech plays a more remarkable role in enhancing reg in provinces with relatively low level of reg. In other words, their nexus is asymmetric. Results from the moderating effect show that digitalization can help fintech better promote reg because the interaction of digital economy and fintech also show a positive partial impact on reg, which verify the synergic influence of digital economy and fintech. Results from moderating effect tell us fintech indirectly influence reg through the innovation of green technology, such as renewable energy technology patents. So let me also provide some policy recommendations. Enhance financial technology for renewable energy growth, promoting local investment. Policymakers should use stable financial means to stimulate local investments in renewable energy. This includes increasing green credit capacity, raising investment level in renewable energy companies, leveraging big data, AI, cloud computing for enhancing the role of financial technology in promoting renewable energy and green technology, strengthen data sharing and coordination, establishing a green financial big data platform to support the development of energy enterprises, strengthen climate and environmental data sharing and coordination mechanism among government, enterprises, and financial institutions. Develop and improve digital economy. So how? Through investment in digitalization of energy sector, deploying smart grid technologies, integrate renewable energy sources to improve efficiency and reliability of the energy system, or encouraging renewable energy microgrids, promoting the development of renewable energy microgrids managed by digital platforms for efficient and flexible management of renewable energy sources, attract investment in underdeveloped regions. This is one of the main policy recommendations of this research for China in order to have a homogeneous development in all sectors and low disparity in energy transition. This is important to pay more attention to those underdeveloped regions, introducing more incentives. Also for investment, those regions have higher return because there is more capacity over there and comparing to those developed prefectures. Utilizing existing advantages to attract investment from different sources and creating a conducive business environment for the integration of internet technology and reg. So generally focusing on cutting edge technological changes. So China needs new technologies for transition, especially high techs for hydrogen, for geothermal, for wind, for solar, requires the technologies that have higher level of efficiency and lower cost, improving risk management and operation, develop green finance technologies, innovating green investment product using blockchain, big data, and other technologies to improve pricing of green project and assess the green level of projects. Thank you very much for your attention.